Hello again, it's Peter. And in this video, I would like to talk to you about the cost of the experiment that I did in my class, where I had workers, students producing a widget in 1 minute. And let me just give you the results from the first game we played. So we have. Let me give you the results of the second game we played. So there's labor and there's production. They were producing widgets. They used the raw material, right? And a stapler. And if you recall, in 1 minute, each worker was producing widgets by folding this piece of paper twice and stapling it. And then we were changing the amount of labor on a piece of land, and we're changing the amount of labor, and we're observing production at different levels of labor. Yeah. So zero workers, zero labor. Sorry, zero workers, zero production. My God, sometimes I don't know what I'm talking about. One worker, 7 units of output. Two workers, 17 units of widgets. Three workers produced 21 widgets in 1 minute. Four workers produced 24 widgets in 1 minute, and five workers produced 25 widgets in 1 minute. Yeah, so that's the production function. And then I gave them cost, and I said that you have a fixed and variable cost. Fixed cost would be, I assume they are $2, and fixed no matter what the level of output is, and your variable cost were what was it, $1. It was $1 per worker per minute, so they can make lots of money, $60 an hour to produce this silly product. So if you let's put a table here. So the first one is the total fixed cost for the land and I guess buying the stapler, renting the land. You had the electricity, I guess also, and you had also managers, etc. So all those for the fixed factor production. And so no matter how much you produce, you would be inquiring $2 of fixed cost. $2, $2, $2, $2, $2, $2. Your total variable cost, of course, varied with labor. You use no labor, then you produce nothing. Therefore, your variable cost is zero. If you used one worker, you inquire the variable cost of $1. It could be a combination of raw material, etc. And there's all the variable factors of production. Uh, then two workers $2, three workers $3 per minute, four workers $4 per minute, and five workers $5 per minute. Yeah. Um, that's total variable cost, and total cost would be the total fixed cost plus total variable cost. So it's equal to $2, $3, $4, $5, $6, and $7. Yeah. And then we can go to unit cost, and when we go to unit cost, we can figure out average fixed cost, which is basically total fixed cost divided by production, right? So it's undefined that it's very infinite at the zero level because you're incurring some fixed cost and you're producing nothing. Then this $2 divided by 7 units, and that's comes out to about for 7 units comes out to about 28 cents, 29 cents. Let's make it 0.286 cents. For 17 comes down to 11 cents or 19 cents. Then at 21 units, it is not about 10 cents, 0.095. At 24 units, it is a 0.083, and then at 25 units, it's 8 cents. So you can see that as production increases, your average fixed cost tend to decline continuously because you're allocating a higher level of production onto a fixed cost. So your average fixed cost decline as production increases. Yeah. And then average variable cost would be, so there's lots of numbers here. Average variable cost would be total variable cost divided by Q. Here, let me put the formulas up here. So average fixed cost is total fixed cost divided by production. Average variable cost is total variable cost divided by production. And here it would be 1 divided by 7. And that would give me 14 cents, 1.143 to be precise. The total variable cost at 7 units of output. At 17 units of output, it's 2 divided by 17, and that would give me 0.118. At 21 units of output, we are here. It would be 14 cents about. Then 24 units of output, it will be 16 cents. And about and at 25 units of output, it will be 20 cents. Yeah. Average total cost is just your unit cost, total unit cost. So it'll be average fixed cost plus average variable cost, and that would, you just add up these two numbers and you get about 43 cents. 24 cents about, 24 cents, 25 cents, and 28 cents. Yeah. And you can compute also marginal cost of production. And marginal cost of production is the change in total cost of production, or total variable cost of production, total cost of production, the change in total cost of production for a change in production, per unit of change in production. So 3 minus 2 divided by 7 minus 0, or 4 minus 3 divided by 17 minus 7. Okay, and if you do that, you'll get the marginal cost of production for the first unit is, I tend to put it at half because we're really approximating it around 0 to 7 units. So it would be between these 0 to 7 units. So it will be 0.143, 0.1, 0.25, 25 cents, 33 cents, right? So here you have the total cost always increases by $1 in this example, and production would change by the marginal productivity of labor, right? So because the marginal productivity of labor is declining, it's pulling up your marginal cost of production. That you can see easily, and then it reaches $1 at $1 when you change from 4 to 5 units of labor, because that extra worker produces only 1 unit of extra output, and it's costing you $1 extra, right? So you can graph these unit costs, and when you graph these unit costs, oh, I'm approaching my 10-minute mark. So, but when you graph this unit cost here, let me graph the unit cost, the unit levels. So I'll put production here, Q, and average cost, average fixed cost, average variable cost, and marginal cost on this axis. Okay, and in the general tendency, I'm not going to graph this particular example, but I'll leave it for you to do as an exercise. But if you graph it, you'll see basically that average fixed cost declines throughout. average variable cost here initially declines and then starts rising. So we have a little bit of a decline and then reaches a minimum and then starts rising. That's average variable cost. And average total cost would be initially declining also because it's a combination of average fixed cost and average variable cost. So it would start up somewhere a lot higher than somewhere around here, I guess, and then it would be declining, reaching a minimum and then start rising again. That's average total cost. Okay, initially it's declining because average fixed cost is a big component of it. And average fixed cost is declining, therefore it's much more powerful than the average variable cost, which could be increasing. But asymptotically, average variable cost and average total cost will tend to go together because your average fixed cost will be declining throughout. So we see less and less weight into the average total cost. Okay, and the marginal cost will initially fall, and it's falling because of the increasing returns here, because you can see the first worker produced only 7 units of output, but the second worker produced 10 units of output. So the second worker was more productive than the first worker, and that we call increasing returns. And you can observe it probably because of division and specialization of labor. But then eventually diminishing returns will enter. So once diminishing returns enters, marginal cost of production starts rising, and starts rising very, very fast. So and it goes through the minimum points of the average total cost and average variable cost. So that's marginal cost of production. Yeah. Okay, so the idea here is that average total cost falls and then starts rising. Average variable cost also falls, reaches a minimum and then starts rising, and average fixed cost tends to fall throughout. Yeah, marginal cost falls initially due to increasing returns and then starts rising due to diminishing marginal returns. Yeah. The other thing to observe is that as long as marginal cost is less than average cost, average total cost, or average variable cost, uh, what average total cost will fall. And if marginal cost is above average total cost, average total cost, average total cost will rise. And if marginal cost is equal to average total cost, then average total cost either is at the minimum or will not change. And the same applies to the average variable cost. As long as marginal cost is below average variable cost will be declining. When marginal cost is above average variable cost will be pulled up. Yeah, and that's it. A bit above again. The time. The other thing that I did with this class was that I gave them another state when the 4 workers were working. I gave them another stapler and I asked them to produce widgets in 1 minute. So they divided work again. Two were using staplers and 2 were folding, and so they were kind of had a like two separate firms in a way within the same space. So one worker was folding on one side and the other guy was stapling. One worker was folding on one side and the other guy was stapling. And recall that they were producing 17 units with 2 units of labor. With 4 units of labor and 1 stapler, they were producing 24. But with 2 staplers, they produced double the 17. They produced 34 units, which kind of shows you that you have constant returns to scale in a way. Although eventually, if I had another stapler and another worker, probably diminishing returns will enter there because the land was fixed, the space was fixed. Okay. Anyway, I'm into 15 minutes, so I overdid it. Bye now.